notice, and this is the regular copyright. We are looking at mathematics syllabus CSEC, effective 2018 and runs up to 2027. Just a reminder that the syllabus is divided into 9 sections. The exam is made up of a paper 1, 60 multiple choice questions, paper 2, assortment of structured questions, and a paper 3, if you are in school, that would be SBA, and if you're not in school, it will be an alternative to the SBA. In all papers of the exam, a formula sheet will be provided. Silent electronic non-programmable calculators are permitted in papers 2 and 3, but not in paper 1. Which brings us to one caveat, and that is you will need to know the times tables 2 to 12 if you hope to pass this exam. Now, this is one that we are familiar with from primary school, and some people may have seen it in this format. So, schedule of videos. Section 1 has 32 videos that I'm hoping to finish in September 2024. Section 2, maybe 13 to 15 videos in October 2024, and so on. Section 3, Section 4. Section 5 next year, 2025, January. Section 6, Algebra. 7, March 2025. April 2025. Section 8, Trigonometry and Geometry. And Vectors and Matrices by May 2025, but I will try to get most of this section done by April 2025 for those who want to write exam in 2025. As you are aware, I have divided section 1 into 32 videos. We have already dealt with video 1, sets of numbers. Now we are at video 2 in section 1, types of numbers. And then we still have to go up to video 32 in section 1. I have divided objective 1 into 4 sections. We are now at section 2. We will be talking about even numbers, odd numbers, prime numbers, composite numbers, and square numbers. In the last video, we grouped numbers in terms of their historical discovery and usage. Now, in this video, we will group numbers in terms of their characteristics. And of course, there will be some overlap among the groups. So let's begin with even numbers. What are even numbers? Now, if you have some stars like this here, and you were to count them one by one, you will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we counted each individual star up to 10. But you can do this faster if you count in groups of 2s. So let's go 2, 4, 6, 8, 10. So now we counted in 2s, 2, 4, 6, 8, 10. And of course, if we had more, we could go up to 12, 14, 16, 18, and so on. We could keep counting in groups of 2s. You will notice that each of these natural numbers can be divided by 2 without a remainder. You could divide 2 by 2 without a remainder. You could divide 4 by 2 without a remainder. You could divide 6 by 2 without a remainder. You could divide 32 by 2 without a remainder. Now, any integer, including negative numbers, but excluding 0, that can be divided by 2 without a remainder is called an even number. So that's what an even number is. Now we go on to odd numbers. If we count by 2, those stars, that's 2, 4, 6, 8, 10, and we have 1 remaining. Now, odd numbers are not even numbers. So either a number is even or it is odd. We know what an even number is. It can be divided by 2 without a remainder, which means that any number that divided by 2 with a remainder, which is 1, will be an odd number. If you divide a number by 2 and there is a remainder, which will always be 1, that original number is an odd number. So odd numbers are located between 2 consecutive even numbers. Example, between 6 and 8, there is 7, which is, of course, an odd number. So to review, we have talked about even numbers and odd numbers. If we have a box like this and we label it integer, we'll put integers that we have met so far. We can put all even numbers in a circle like that. We can put all odd numbers in a circle like that. So if a number is even, it cannot be odd. And if it is odd, it cannot be even. And of course, we put 0 here as well. So far we know what even numbers are, we know what odd numbers are. Take 24, for example, and 62, and 17, and 55, and so on. Where will we put these? Well, if the integer ends in 2, 4, 6, 8, or 0, it is an even number. So 24 is an even number, 62 is an even number, 17 is an odd number, 55 is an odd number, negative 80 on this side here is an even number, negative 81 is an odd number, 198 is an even number. It can be divided by 2 without a remainder. And this extremely large number here, 28,357,210, it can be divided by 2 without a remainder. And so that is an even number. Now, 0 by itself is not even, and it's not odd neither. 0 by itself. But if a number ends in 0, it's an even number. So now let's go on and talk about prime numbers. Most integers can be divided by itself by 1 and by 1 or more other smaller integers. For example, 8 can be divided by itself, can be divided by 1, can be divided by 2, can be divided by 4 without a remainder. 20 can follow the same pattern. It can be divided by itself, by 1, by 2, by 4, by 5, and by 10. Now, but a few integers can only be divided by itself and by 1. Now, 5 can be divided by itself and 1 only, nothing else, without a remainder. 13 can be divided by itself and 1 only, without a remainder. Now, integers that can only be divided by itself and 1 are called prime numbers. Prime numbers, let's see where we will put that in our diagram. So you have this box here contains all the integers that we have met so far. We have even numbers over here. We have odd numbers over here. We have 0 there as well. Where will we put prime numbers? In this diagram. So the prime numbers up to 50 are 2, 3, 5, 7, 11, 13, 17, and so on. Notice most of them are odd numbers except for 2. So 2 is an even number that is prime, and all these other numbers that we see here, 3, 5, 7, 11, and so on, they are odd numbers, and they are also prime numbers. So we will put a new group like this, and except for 2, all prime numbers are odd numbers. So we put 2 here, and all these other prime numbers that we have here, we put them in this section here. They are odd numbers and they are prime numbers. So you put 3, 5, 7, 11, and so on. They are both odd and prime. If you find this video useful and interesting, please like and share. Like and share. And you may also consider subscribing to this channel. It does not cost you anything, and it means a lot to me. All right, now we will talk about composite numbers. As we said, most integers can be divided by itself by 1 and by 1 or more other smaller integers. We already looked at 8. 8 can be divided by itself by 1, by 2, and by 4. 20 can be divided by itself by 1, by 2, by 4, by 5, by 10, without a remainder. Now, these smaller integers that can divide a larger integer without a remainder are called factors of the larger number. So 2, for example, is a factor of 20, 4 is a factor of 20, 5 is a factor of 20. But the large numbers that can be divided by the smaller numbers that may or may not be prime numbers themselves are called composite numbers. So in this case, 20 will be a composite number. It has more than 2 factors, itself and 1. It has more than those 2. 8 also has more than 2 factors, itself and 1. It also has 2 and 4. So composite numbers, your definition from your syllabus says that composite numbers are numbers that have more than 2 factors. For example, 6 and 20 are composite numbers, while 7 and 41 are not. They are prime numbers. So let's go back to our diagram and place composite numbers in it. So we have this box here that contains all the integers that we have met so far. We have even numbers in that circle. We have odd numbers in this shape. They do not mix. A number is either even or odd. 0, of course, is out here. Prime numbers, you could have odd numbers that are prime numbers. You could have even numbers that are prime. Well, only one, which is 2. 2 is the only even number that is prime, and all the other prime numbers are odd. For example, 3, 5, 7, and 11. Okay, where do we put composite numbers here? Composite numbers are numbers that have more than 2 factors, itself and 1. So we have to change this diagram a little. We'll make it like this now. Even numbers here, odd numbers here, prime numbers in this circle here, which we have 2. It's an even number and a prime number. And we have other prime numbers that are odd numbers. Now we make a new shape down here, and we will put composite numbers here. Notice that if a number is composite, it cannot be prime. If a number is even, it cannot be odd. Those are exclusive sets. However, a number can be even and prime. It can also be even and composite. It could be odd and prime. It could be odd and composite. So let's consider 6. 6 is an even number, and it is a composite number. It has more than 2 factors, 20, -18, and -30. Those are all even numbers that are composite. Now let's look at some odd numbers that are composite. 15, it has more than two factors, 1, 3, 5, and 15. 21 has more than two factors. 35 has more than two factors. And so these numbers here are odd and composite. Now remember, if a number is composite, it cannot be prime. And if it is odd, it cannot be even. So now we will go on to talk about square numbers. Well, what are square numbers? Now consider this grid here. If you have a square in there that is 4 by 4, what is the area of this square? How many little squares do we have? If we count them one by one, we will get 16. However, we can just multiply 4 by 4 and we will still get 16. So 4 by 4 is 16. Now, notice that in order to get 16, we had to multiply 4 by itself. So 16 is the square number. The number that you squared to get it is 4. So 4 squared will give us 16. 16 is the square number. The number that you squared to get it is 4. Let's take another shape, 7 by 7. If you count them, you will get 49. You could just multiply 7 by 7, and you will get 7 times 7 is 49. 49 is the square number. You square 7 to get 49. So 7 squared will give us 49. The square number is 49. What you squared to get it is 7. Now, CXC does not provide a definition for square numbers. 15 by 15, multiply them, you get 225. So 15 squared, that is 15 multiplied by 15, would give 225. 225 is the square number. The number that you square to get it is 15. A square number is the answer you get when you square, that is, multiply it by itself, any integer, and that includes 0. Note that. So 15 squared, you get 225. 225 is the square number. 10 squared, you get 100. The 100 is the square number. Negative 8 squared, you get 64. 64 is the squared number. The number that you squared to get that is negative 8. 1 square is 1. 1 is a square number. Negative 1 square is 1. This is a square number. And 0 squared is 0. 0 is a squared number. Now you take any integer and you multiply it by itself, you will get a square number. Or another way to put it is a square number is the squared of any integer, n squared. Now if we look at this times table here, we begin at 0 at this point and we come straight down and across like that arrow. All of those numbers that you see there are squared numbers. So 0, 1, 4, 9, 16, and so on. They are all squared numbers. So now, where are we going to put square number in this diagram? Let's change up the shape a little. We're going to put all integer in this lime green box we see here. We put even numbers over here and odd numbers over here. I am again emphasizing that if a number is even, it cannot be odd, and the other way around. We will put prime numbers up there, and the one even prime number we know is 2, and we have some other odd prime numbers. So we put them in this section here. They're odd and they're prime. Then we looked at composite number, notice that if a number is composite, it cannot also be prime. By definition, prime number has only two factors. Composite numbers has more than two factors. Okay? So some odd numbers that are composite are 15, 21, 27, and 35. They are odd and they have more than two factors. Some even numbers that are composite are 6, 20, negative 18, and negative 30. They have more than two factors and they are even. Now we want to fit square numbers. Now these are our square numbers on the right here. We have to get another shape somewhere in between here, which looks like this. So in this latest shape here, this one in the middle here, we will put square numbers. So if we have an even number that is square and that is composite, it will go here. If you have an even number that is a square number, it will go here. If you have an even number that is a composite number, it will go here, and so on. So we fit 0 in this point. Remember, 0 is a square number. 1 is also a square number, but it is also an odd number. So it goes in this section here. Then we have 4, 16, 36. Those are square numbers. They are also composite numbers, and they are also even numbers. So these numbers fit in this section here. Over on this section here, we have odd numbers. They are odd numbers. They are square numbers, and they are also composite numbers. So let's review and see how much we can remember. Now I will change up that diagram a little. So we have all integer in this lime green rectangle here. In this shape, this oval shape, we will put odd numbers. Now remember, that is slightly different from what we had before. We will put even numbers in this red oval over here. In this purple here, we will put prime numbers. In this green circle here, in this green oval here, we will put composite numbers. And in this yellow oval, we will put square numbers. Let's label some regions. That is A over there, which is odd number alone and nothing else. B would be even number alone and nothing else. C will be prime numbers alone. D will be composite numbers alone. E will be square numbers alone. Now F will be odd number and prime number. If it's both odd and prime, we put it at F. G, if it's prime and even, it goes here. H, if it's odd and composite, it goes there. J, if it's even and composite, it goes here. K, if it's odd and square, it goes here, K. L, if it's even and square, it goes here. N, it must be composite and square. But you know, we wouldn't have anything there as N because it would either be even or odd. So we really wouldn't have anything in N. Now P, it would be even, it would be square, and it would be composite. That's P. And of course, R will be odd, composite, and square. So let's look at these first 15 numbers here and see where we can place them. 0. Where do we place 0 here? Now we said 0 is a square number, but it's not a composite number. So we will place it at E. So 0 goes here at E. 1. 1 is a square number, and it's an odd number, but it's not a prime number. So it's square and odd. So 1 goes at K. 1 goes there. Let's deal with 2. 2 goes at G. It is even and it is prime. It is not composite and it is not square. So 2 goes here. 3. Now 3 is odd. It is prime. It is not composite and it is not square. So 3 goes here at F. Let's look at 4. Now we know that 4 is even and we know that it is square. Now, is it also composite? Does it have more than 2 factors? Yes. So 4 goes at P. 4 goes here, P. 5, well, we know 5 is odd. We also know it's prime. We know it's not composite and it's not square. Therefore, 5 goes at F. 5 goes here. Let's consider 6. We know 6 is even. We know it is composite. It has more than 2 factors. But it's not square. So 6 goes here at J. Let's look at 7. 7 we know is odd. It is also prime. It has only 2 factors. And if it's prime, it's not composite. And of course, it's not square. So 7 goes here at F. Consider 8. 8 is even, so it will fit in this red oval on this side here. It is composite. It has more than 2 factors. It is not prime, and it is not square. So that 8 goes at this point here, J. Consider 9. Now, 9 is odd. It is also square, and it is also composite. So where do we put 9? We put 9 at R. So 9 is odd, square, and composite. Fits at R. 10, we can see 10 fits in J. That is to say, 10 is even, and it's composite, so it must be even and composite. It's not square. So of course 10 fits at J. 11 we know is an odd number and it is prime, and therefore it cannot be composite nor square. So we fit 11 at F. 12 is an even number. It is composite. It has more than 2 factors, but it is not square. So 12 goes in this section here, J, which is even and composite. 13 we know is a prime number and an odd number. 13 is prime and odd. So 13 goes where that F is. 2 more to go. 14. 14 is an even number, so it has to fit in this red oval here. Is it square? No. Is it composite? Does it have more than 2 factors? Yes. You have 1, 14, you have 2 and 7. Therefore, 14 will be even and composite. We fit that here at J. And finally, 15, we know it's an odd number. We know it's a composite number. It's not a square number. So 15 goes here at H. Now, one last thing before we move from here. Negative integers. For example, -1. Now, we said that 1 is a square number and an odd number, but -1, it is only odd, it is not square. What do you square to get -1? -2 as well, be careful with that. We fit that at G. It is a prime number and it is an even number, so -2, we will fit that here in G. -4. Now, you may think that -4 is a square number, but no, what do you square to get -4? Nothing. So -4 is an even number. It is a composite number, but it's not a square number. So -4 goes here. -9, do not be fooled. -9 is not a square number. It is an even number and it is a composite number, but it is not a square number. So -9 goes here. And finally, we look at -16 again. 16 is a square number, it is a composite number, but -16 is not a square number. It is an even number and it is a composite number. So we put -16 here. And that brings us to the end of video 1.12, which is the second video that deals with numbers. We looked at the grouping of numbers in terms of their characteristics. So as I said, that brings us to the end of this video, which is video 2 of 4 from section 1, objective 1.